In this video, we're going to explore some of the basic terminology that we're going to use, and specifically what we're going after, what our ultimate goal here of this first part of the course is to look at how we measure engine performance. And particularly, we're going to look at power output. How do we measure power? How do we describe that? How do we put a number on it? How do we quantify it? And so we're going to be getting to this equation where power is force times distance over time, or for an engine, it is torque times speed. But before we get there, let's look at some fundamental concepts of force and torque, work and energy, and then ultimately put those together to get power. So that's where we're going to go. So let's start with force. What is a force? Well, I think most of us have a pretty good concept of what a force is, and we can define it as pushing or pulling of one body on another. And that's pretty straightforward. As you see in the picture, if we're pushing on a car, we're putting a horizontal force that we're pushing away of that car and trying to get that car out of a ditch. We could have a pulling force like you see on the tractor over here, where we've got the tractor pulling on this wagon, and that's a pulling force or a tension force. The forces could be in any direction. So, of course, I'm putting a force on the floor because I'm standing here, or actually the Earth's gravitational pull on my body is creating a force on the floor. And then, like Sir Isaac Newton said, there's got to be an equal and opposite reaction, so the floor is actually creating a force upward. So we could spend a lot of time talking about forces, but I want us to at least get our heads wrapped around this concept of force that we measure in units of pounds in the English system, and that's pretty common. We all understand that, or understand our weight and so forth. We're also going to look at the SI units throughout this course. And so in the SI system, the force is measured in units of newtons, and so that's what the N is. It's a newton. So we'll be using both of those, and we'll see how to calculate both of those units as we go through this. So that's a force. Force is linear. It can be in any direction, okay? Now, what's a torque? We start talking about torque, now we're talking about twisting. And so the torque is the ability of a force to cause an object to rotate. So I've got some object and I want it to rotate. And so I'm going to use a force somehow to make that object rotate. Well, how do I do that? Well, it's a force applied at some distance from the center of rotation. Oh, what does that mean? Okay, well, let's look at a common example. So I've got a bolt, and I need to loosen this bolt, okay, and it's tight. So what do I need to do? I need to twist this bolt. So I need to put a torque on this bolt. So I grab a hold of it and I twist it, and I can do that with my hands. I can do that by twisting it, and so I'm using the twisting motion. I'm using a lot of internal forces in my wrist and everything else to be able to turn that. But let's say that that thing is too tight, and I get a hold of it. I can't grip it hard enough. I can't turn it hard enough. I can't make that bolt turn. So what do? Get a wrench, of course. So I maybe use a wrench like this, and we'll look at these wrenches in lab, but this is a ratchet and it's got a socket on the end of it that's the right size. So I put that socket on this bolt. Now look at what I'm going to do. I've got this ratchet on here, and here is the center of rotation of the bolt right here where that socket went on. But I'm going to grab this wrench out here at the end of the handle, and I'm going to pull down. So what am I doing? I'm putting a linear force on the end of this handle, pushing down on that handle, and that's going to hopefully cause this bolt to rotate. Okay? And we can quantify that, and we'll do that. Let's take a look at how we might quantify these numbers. So let's say, for instance, I've got this wrench here, and I got my tape measure out, and I measured the distance from here to here, so I know how long the wrench is. And let's say that I have an idea of what kind of force I can put on there. Let's just say, so we can throw some numbers down, maybe I have the capability of pulling 80 pounds of force. So that's what I can put on here, and I put that 80 pounds on here, and I'm putting that twisting motion then. So how much torque is that? Well, let's calculate. So let's go to our slides here, and let's look closely at what's going on. So I've got this ratchet. Here's a picture of this ratchet that I was working with. And remember, I measured the length of that ratchet from the center of where the bolt is to the handle where I'm going to put the force. Here's where I'm going to apply the force. So I'm going to make that big arrow there. That's where that force is going to push on the end of that handle. And this distance is 9 inches. So I measured that with a tape measure. And remember, I said that I have the capability of pulling 80 pounds of force on the end of that wrench. Okay, so how much torque is that? Well, how do we calculate it? Here's my equation. Torque is equal to the force times the R, or radius, or the distance away from that rotational point. So, write it down here. Torque is equal to force times R, the radius. What is my force? My force is 80 pounds. That's what I have the capability of pulling. Multiply that by the radius, which in this case is 9 inches. And I put that in a calculator, or know that 8 times 9 is 72. And that tells me that I have 720 what? What units is that? I have pounds and inches. So it's pound inches or inch pounds. 720 inch pounds. That's the torque that I can put on there. Well, now let's say that, okay, I don't want inch pounds, I want foot pounds. I want to be thinking about this in foot pounds. So how many foot pounds is that? Well, I can convert that from inches to pound because I know that there are 12 inches in a foot. So I can multiply this number, multiply 720 inch pounds, by a fraction. And so we can think of this as a fraction all over 1. 720 inch pounds is over 1. I'm going to multiply that by 1 foot for every 12 inches. Like that. So foot over inches. Now what's interesting here is I have inches in the denominator, I have inches in the numerator in this other part, and I can cancel those inches off. What I'm left with is foot and pound. So that's my foot pound. That's what I want. So I take 720 divided by 12, and that is 60 foot pounds. All right? If that math was a little bit crazy, we're going to come back and learn some more about that. We're going to learn some of those techniques and how we use these units to cancel out and stuff like that. But there is my torque. That's what I was able to create with my wrench. Okay, so let's think about that. Here's the wrench that I had. Put 80 pounds on it. And that created a certain amount of torque that would hopefully loosen up that bolt. Now, incidentally, we're going to look at some more tools in lab, but we have tools like this torque wrench that'll tell us that torque directly, and we'll see them. But as I pull on the handle on this torque wrench, and this wrench, I can put the same socket on the end of this wrench as I have on this particular wrench, and as I pull on it, this indicator is going to move to the side, and it's going to tell me how many inch pounds or foot pounds of torque that I'm applying to that thing. Okay? So that's what torque is. That's the idea. Now, let's think about this. Let's get practical. So I had this bolt. Let's say it's an old and rusty bolt, and I put this wrench on it, and I pulled on it with the 80 pounds that I have the capability of doing, and it didn't come loose. So now what do? Well, I have two options. Think about torque. Two components that are in torque. There's the force, and there's a radius. So I could go find somebody that's stronger than me, and they can put more force on the end of this wrench. That might be something that would do it. It might be able to break that bolt loose. Or, what do we commonly do? We try to make the distance a little bit bigger. So I go to my garage, I find a piece of pipe, and I stick a pipe on the end of this wrench. Now, this is generally not a good idea with the ratchet because we can damage the internal workings of the ratchet, and we'll talk about that. There's some other wrenches I'll show you in just a second that would do a better job at it, but this would create more torque. What am I doing? I still only have the capability of pulling 80 pounds, but now I'm pulling that 80 pounds way out here, a long way away from that rotation. So I've increased that moment arm, increased that radius, and I've created more torque. So how much more torque? Let's take a look at it. Let's go back and calculate it. So what I should have used is a wrench more like you see on the bottom here. So this is what we call a breaker bar, and it's just a longer ratchet. It doesn't ratchet. It doesn't have the mechanism in it that can damage easily, and it's meant just to be a longer wrench to be able to break things loose. And so that's what I would want to use. And this wrench, if I would buy this one from Lowe's, this one is actually 15 inches long. So it's 15 inches from there to the end where I'm going to put that force. So I'm going to put that same force out there, still 80 pounds, but how much torque am I creating? Torque is equal to force times the radius is equal to, what's my force? Still 80 pounds. That's all I can pull. That's my limitations of strength. So 80 pounds times, now how long is my wrench? It's 15 inches. And what is that torque? Is 1,200 inch-pounds. So that's what my torque would be. So notice what I've done here now. So by increasing that length, I've almost doubled, and it's true, I almost doubled the length of the wrench. And I've greatly increased the torque, so hopefully I have a better ability now to break that loose. So that's the concept of torque, okay? It's a twisting force. It's something that twists. Now, what we're also going to have to think about as we go through this and we start looking at dynamometers and measuring engine output is the torque might not be causing it to rotate. The torque might be resisting the rotation. So I might have something that is trying to keep something from rotating. So it's like a negative force in some ways. And so that torque can happen a lot of different ways, but it's that twisting force. And that's really important. It's something that we're really going to have our heads wrapped around as we go through this and understand torque. So make sure you understand that. Make sure when we say torque that you know what that means. Okay? So that's torque. So let's look now at work and energy. Okay, so when we talk about work and talk about energy, now it's starting to get a little bit more abstract. But again, it's very important concepts that we need to understand. So work is a force applied through some distance. And it's measured, and look at this, look at the units, pound feet, or in the SI system, it's a Newton meter, so it's a force times a distance. Looks a lot like a torque, doesn't it? So it's the same units. It's kind of the same basic concept, okay? But this is energy, all right? So one way, the practical way to think about it is a force applied through some distance. Think about a power lifter. They're lifting that barbell up off the ground, okay? So how heavy is that barbell? That's the force that we have to overcome. How high am I going to lift it? That's my distance, and that'll tell me how much work I do. So if that's a 300-pound barbell, and a deadlift like that usually moves that barbell about 2 feet. So 300 pounds times 2 feet is 300 times 2 is 600. So it's 600 foot-pounds of work that I have done. Okay, so that's the work. It's a force applied through some distance. I could do the same thing if I'm pulling a chain. So, and we'll do some examples where we think about somebody pulling something. How much force can they pull and how far do they pull it? We can measure the work, the amount of work that we do. So it can be going horizontally, it can be going vertically, and so forth. Now, what's the difference between work and energy? It's really a lot of the same things. Physicists will really start splitting hairs on this. For practical purposes for our class, we can think about them as the same thing because the energy is the capacity to do work. So if that power lifter there used 600 foot-pounds, did 600 foot-pounds of work, that person had to have 600 foot-pounds of energy in them to be able to expel, to be able to do that work. And so it's kind of like, it's the energy that we use to do work, and there's got to be some equivalency there. So if I'm going to do work, I have to have that much energy to be able to do it. I can look at the energy and say, how much capacity do I have to be able to do work? And again, it's all measured in the same units. Now, sometimes you'll see people that'll get really, really technical, and when they talk about units of work, they'll talk about pound-feet, and if they go to energy, they'll do foot-pounds. They'll flip them around a little bit just to kind of be clear on that. Again, for the practical intents and purposes in this class, we're going to treat them as pretty much the same thing. So that's what the energy is. That's what energy is. How much energy, their capacity to do work. And we're going to see this a lot more when we look at engines. You think about engines, this capacity of energy. We have fuel that we're putting into that engine that we're converting to do some type of mechanical work to make a shaft rotate. Well, how much energy was in that fuel? And how much energy did we get out, and how efficient is the system? And so we're going to look at energy and work and all that kind of stuff in a lot of different ways. So that's where we're going to go from here, is looking at that energy stuff. Now, talked about force, we got torque, we got the work and energy, thinking about work and energy. What's the last thing now? We can put them together and do power, because the power is the rate at which work is being done. Okay? So work is how heavy it was and how far I moved it. So when I lift that barbell off of the floor, how much work did I do? That 600 foot-pounds, 300-pound barbell lifting it 2 feet. That's how much work that I did. Now, the power is how fast did I do that work? So if it took me 5 or 6 seconds to strain and grunt and get that bar up there, I didn't really exert a lot of power. But if I grab that barbell and I lift it really quickly, I exerted more power. Okay, you see the subtle difference there? It's the same amount of work, but I did it a lot faster. Okay, so that's what we talk about, the rate at which work is being done. When we look at units, we're going to start breaking this down, understanding the fundamental parts of it. The power is the work that we do per unit time, is work divided by time. What is work? We said the work was a force over some distance, so it's force times distance that we can do in a certain amount of time. So how much can I pull, how far can I pull it, and how fast can I make it happen? Okay, that's power. And so that's where we go. Now, we can break that down even more, and we can, if we look at our English system, force times distance over time, we could say that's a pound times a foot in a second, pound-foot per second. Now, most of us don't really think about foot-pounds per second, but what we do think about in power is horsepower. So a foot-pound per second, it's a direct conversion from foot-pounds per second to horsepower. That's what we understand for power. So that's where we're going to get there. And we'll do some examples in the next video where we show how that happens, how those units all come together and everything. But that's what power is, work per unit time. Foot-pounds per second or horsepower in our English system. And in our SI system, then we're looking at Newton meters as the force times the distance per second. And that unit is actually a watt. So when we talk about how many watts of power in the SI system, and typically when we talk about an engine, a watt is pretty small, so a lot of times we'll be looking at kilowatts. And a kilowatt is 1,000 watts. And so a kilowatt is somewhat similar to a horsepower. They're pretty close in size to what a horsepower is. So those are the fundamental units that we'll be looking at in power. And again, we're going to do some examples and show you how to calculate it, show you how the numbers break down and practically how we do that. And we're actually going to be measuring this on an engine. So when we talk about rotational power, if we get specific now, if we talk about that rotating shaft that's coming out of an engine, that's what an engine's doing, is making a shaft rotate, and that's what we're using to do work. That's where my power is that I'm getting out of the engine. It's in that rotating shaft. So how do I calculate that? That power is torque times speed. Again, what are units of torque? Torque is a force times the distance, Newton meter or foot-pound, something like that. And what is speed? Typically, we measure that in revolutions per second. Oh, revolutions per second. There are revolutions per minute. So there's my time in the denominator. And we're going to have to do some units conversions and stuff like that to make it all work out. But this is the fundamental equation that we're going to be working with. And this is where it all comes from. So concepts that I want you to make sure you understand. The concept of what a force is, what torque is, and understanding that rotational force. Understand where energy is. Okay, what is energy? Where does it come from? And how do we describe that? And then how do we get to power? So power is how much energy that we use or how much work that we do and how fast we do it. So we got to have those two components in there to make that happen. So that's what power is. Again, next video we'll do some equations and we'll do some examples and show you how to calculate, and it's pretty simple.